there. Good to see you all here. Thank you for coming. I want to talk about how hard it can be for geospatial data practitioners, whether that's researchers or data scientists or analysts, artists or engineers, to adapt to working with their data in a programming paradigm using open source libraries instead of proprietary software. There are a lot of people in this picture here. Proprietary software has kind of had a strong hold over government, education, and industry for a long time now. And moving towards a programming paradigm is becoming kind of a more and more necessary part of the job, whether you're using proprietary software or not. But it's still very hard. So to kind of help you quickly get to know geospatial professionals, this is the kind of thing we think is really funny. Here's our official Halloween costume. Happy belated Halloween. Note at the end there, not included, tiers for use in case of software crashes. And this is the kind of problem that geospatial data professionals using proprietary software often enjoy. This is kind of hard to read, but the error up there says error 999999. Something unexpected caused the tool to fail. Contact technical support. And please forgive me, Esri friends in the audience, for the little ribbing. So all the open source folks here are probably thinking we can do better than this. And we can, and we have with amazing projects like QGIS and Pangeo. But also, this is the first web result that I get when I search for Python geospatial visualization tools on Google. So imagine, put yourself in these shoes, being told that you definitely need to learn 37 new tools to adapt to a new way to do your job. And as a software engineer, I see myself in these images, and I want to be better for my friends. So hi, I'm Matt Fisher. I'm a research software engineer and community engagement manager. And I'm also a maintainer of several open source projects. And maybe we've interacted on GitHub before. If not, I hope we do. I'll talk more about Jupyter GIS, which is listed here soon in this talk. But I also want to mention Earth Access. If you work with NASA data, this is one of my favorite community-owned projects that I help maintain. So NASA data is behind a complicated API and authentication system, and Earth Access helps navigate those systems for you and helps you access the data in just 3 lines of code. So please check that out. I'm currently leading the GeoJupyter project at the Schmidt Center for Data Science and Environment at UC Berkeley. And before that, I worked building software for research support and data analysis, visualization, management, and access at the National Snow and Ice Data Center. I also love dogs and gardening and playing music. If you see a dog, please promise me you'll tell me. And in this talk, I'm going to have a lot of links. If you want to scan this QR code, you can view the slides yourself. Hopefully the Wi-Fi will allow you. And I'm going to start by introducing the GeoJupyter community, discuss why it exists, and then I'll introduce and demo the Jupyter GIS software. And finally, we'll talk about how you can join the community. Okay, so what is GeoJupyter? First and foremost, GeoJupyter is a community and a team effort with many players. We'll talk more about those players later. Jupyter GIS is our flagship project, the big blue guy. That's led by QuantStack. And Jupyter GIS is a GIS platform in Jupyter Lab that can be used in similar ways to QGIS, the leading open source GIS software, plus some cool new stuff. So we'll talk more about Jupyter GIS shortly. But it's important to note that our work is not limited to Jupyter GIS. There's lots of question mark bubbles here because we don't know yet what those will be. But we've also got educational work and some kind of aspirational goals here around storytelling, which we'll talk more about later as well. So with all these question marks, we're depending on our community, which is all of you, to tell us what you need. This is just a small slice of our community who came out to Berkeley to participate in a hackathon and design dialogue a couple months ago. I had a lot of fun with that, so I wanted to share this picture. And my first kind of take on how to phrase what GeoJupyter is was an effort to democratize geospatial data practice. But that's not right at all. We're actually joining an ongoing effort to democratize geospatial data practice and bringing the unique strengths of Jupyter to this problem space. People have been succeeding for decades at advancing the democratization of geospatial data practice with projects and communities like QGIS, GrassGIS, PanGeo, and OSGeo. And to explain what we hope to contribute to this space that already has some pretty great things going for it, I want to pause and remember something important, and that's that Jupyter is more than just notebooks. Jupyter is a modular and extensible architecture for interactive computing with powerful and reusable building blocks. So for example, the Jupyter collaboration extension enables users to collaborate on notebooks in real time like Google Docs. And that same collaborative extension provides the foundation for a collaborative computer-aided design experience in Jupyter CAD. This is Jupyter CAD, which is also by QuantStack. So here we can see 3 users collaborating on a part in 3 different interfaces. One of them is a widget and a notebook. One of them is Jupyter Lab, like you've probably seen before. And the third one here is a completely custom interface just for Jupyter CAD, all built from the same building blocks. Okay, so back to what is GeoJupyter. Our mission statement describes us as an open, community-owned effort to reimagine geospatial interactive computing experiences within the Jupyter architecture to enable more people to confidently engage with geospatial data. So maybe the first thing that jumps out is this is really broad, and that's intentional because we don't have the solutions to this problem, but we know we can find them by working with you. So I'd like you to think about what does it look like to you to enable more people to confidently engage with geospatial data, and how can the Jupyter architecture help with this problem? These are the values that we feel are going to help us succeed at our mission. As I mentioned, we build and design in close partnership with our users. We believe in open source and open science, so everything we do is free and open. And to reiterate what somebody said earlier, open source is the best. I really love that. Oops, excuse me. It's important for us to create tools that unify the strengths of current tools and workflows. So we're looking at desktop GIS tools providing approachability and playfulness, coding methods providing flexibility and reproducibility, and Jupyter notebooks providing collaboration and storytelling. And those values have historically been prioritized in separate tools and techniques, but we believe they belong together. And we know that's not going to happen by accident. It's going to happen because software engineers empathized and worked with geospatial data practitioners. So we're building this community because working with data about our planet is hard. What we're bringing to the table is a holistic and human-centered and participatory approach to evaluating and improving this landscape. So far, we've conducted dozens of hours of user interviews to understand what folks need the most, and we're going to continue to use the input of real people to guide our priorities. So let's talk about a few examples of challenges that we've heard through those interviews with practitioners. Many of these challenges have existing solutions, but they often involve either proprietary software or cobbling together multiple tools, introducing workflow friction. So first, geospatial is hard even for the experts, and we all struggle sometimes. So I imagine there are many people here whose lives have been affected by fire or know somebody who has. Brianna is a former deputy manager at a NASA data center, and she lost her home in the recent fires in LA. When Brianna learned that her home was at risk, her first thought, like a true scientist, was to look at the data. And she wrote a post on LinkedIn, which you can see if you follow this link. The QR code will be available at the end again if you missed it. She wrote, "I should be able to do this. I have a PhD in remote sensing. I've built satellite data processing pipelines. I help manage one of the NASA satellite data centers. I teach courses on climate resilience, adaptation, and geoinformatics. And yet, the irony is that with all my experience, I could not access the information I knew existed to help our community." Please read Brianna's full story. Again, link at the top of the slide. Our second challenge that we want to highlight is many geospatial professionals feel locked into certain tools when they want to tell a rich story with spatial data. So scrollytelling is a cute name that I love for these beautiful, rich storytelling experiences. You've likely seen these in the New York Times or some other big media publication. And these are done often by expert programmers and visualization specialists. So for example, Mike Bostock, the creator of the D3 JavaScript data visualization framework, was behind many of the New York Times scrollytelling experiences. And there's also an option of subscribing to proprietary services that have story building tools, but why not open source? So imagine writing a MIST Markdown document or a Jupyter book document that becomes a rich storytelling experience like this. And I do want to give a shout out to our awesome Berkeley friend, Andrew Bray, who's been working on pushing this problem forward with Close Read, a scrollytelling implementation for Quarto. And we're excited to partner with Andrew in the future to develop a MIST implementation with first-class support for geospatial storytelling. I highly recommend checking out the Close Read Prize, which has lots of examples of amazing storytelling experiences built with Close Read. And the last challenge I want to highlight here is that we've heard widely reported by users that there's a lot of friction in visualizing data about our planet from a programming environment like a Jupyter notebook. So we found many practitioners are perfectly comfortable writing code for analysis, but visualizing data is a whole different skill from analysis. And there's a wide variety of visualization libraries out there with unique, sometimes frustrating interfaces, and it can be hard to choose which visualization library you should use. Each choice has a trade-off. So you really kind of need to become an expert in this landscape. And depending on the chosen library, practitioners may struggle to visualize many data sets together, or to interact with the visualization in a meaningful way, or to control the details of the visualization. So to get around this, practitioners described a process with many steps, kind of like a dance, and we heard about this so often that we named it the the GIS bounce. So to do the GIS bounce, first you do some analysis in your notebook, then you write out a data file to check your work so far. If you're working in a cloud environment, you might download that data file onto your local computer, then you bounce over to QGIS, load up a base map, and finally load your data. And now you can validate and then finally bounce back to your notebook and repeat this as many times as you need to check your work in your workflow. And checking your work should not be frustrating or time-consuming. It should be seamless, joyful, and rewarding. So what about a nice interface that can display your many geospatial data sources as layers and a Jupyter widget with some sensible symbology by default? In this code example here, we're just passing some gridded data with no settings and some polygon data with a request to display it as a choropleth map. This doesn't work anywhere. This is just some pseudocode, but we're thinking about what this could look like if things were a little easier to do visualization. So we built something like this in Jupyter GIS, but we're continuing to evolve the idea. Okay, and the landscape of open source geospatial tools is far from perfect. And there's a lot of problems that need solving. And we're far from having all the answers. And this is why we're building a community instead of just a software project. Okay, so let's talk a little bit about some of our work in progress. Jupyter GIS is the GeoJupyter flagship project at the moment, with development led by the amazing folks over at QuantStack, some of whom are here, and you should meet them. They're very cool. So Jupyter GIS is different than most tools. It's an interactive GIS environment, that's standard, but it's Jupyter Lab and browser native, so you can try it out in a Jupyter Hub or in Jupyter Lite. It provides a Python API, which is also interactive, or collaborative. It supports QGIS project files. And with real-time collaboration, you have a Google Docs-like experience, but on a map. And again, that's all under one familiar roof, Jupyter Lab. So this is kind of what it looks like, but I want to actually demo it and show you. So now I need to change to mirrored display. I seem to have lost one of my windows. Apologies. Okay. So here's Jupyter Lab. And we're going to look at how you can use Jupyter GIS in a notebook. First, I want to show you an example of some built-in functionality in Jupyter Lab for visualizing some GeoJSON data. So we've got a variable here with some GeoJSON data in it, and then we're importing the GeoJSON display function from IPython, and we can see some GeoJSON data. With the Wi-Fi, it's taking some time to load the base map. There we go. So this is where we are, Paradise Point Conference Center. And with Jupyter GIS, you can have kind of a similar experience, except with a GIS document underlying everything. So here we're creating a GIS document, adding a raster layer, and then adding a GeoJSON layer from a file. And then we're viewing that data, that document, in a widget. So we've got our base map, and we've got our GeoJSON data layer showing regions in France. And we can visualize, or we can view some underlying data about each of these. I don't know how to pronounce this, but this is the name of the region. And you can also open this up in another tab from the Python API, so you can rearrange your view. But I also want to show you what the underlying document looks like. So here we prepared another document. I'm going to open that up. So we've got some NASA data from the cloud, we've got a base map from the cloud, and we've got an OpenStreetMap layer. And we've got a waymarked layer showing hiking trails in France. So this specific example file, you can check this out as well. If you check out the Jupyter GIS docs, you can click a Try It Now button, and then Jupyter GIS will load up in Jupyter Lite entirely in your browser with no server component, and you can use the same layer and play with it. This is a little noisy, so I'm going to hide this Modis data layer. And then I'm going to use our layer browser. And I'm going to add some Strava running data. There it is. So our layer browser gives you a few options, and we're working on making that configurable so you can add your own data sources to the layer browser. And this is a little bit hard to read, so I'm going to move the hiking trails up on top of the Strava layer, and then we can kind of see where people are running and where the trails are. And I also did a little bit of exploring on the San Diego Open Data Portal before coming here. So let's add a layer from that data portal. I'm going to select New GeoJSON Layer, Browse, open the directory, and let's add this hazards layer. And let's name it. I selected the unexploded ordnance layer because I figured I should be aware. And let's right-click on it and zoom to layer. And it's, again, hard to see things. I'm going to hide some other layers. And I'm going to change the symbology of this layer to make it a little more scary. So let's do yellow fill and a red stroke. Click OK. Now we can kind of see those layers a little bit better. I don't know how to read this data, but let's look at the attributes. This one has something to do with artillery. I don't know what that means, but I'm not going there. All right, cool. And now let's look at some earthquakes data. Let's zoom out in my browser a little bit since these windows are getting kind of in the way. I'm going to hide this, add a new layer. GeoJSON layer, earthquakes.geojson. Let's name it. Okay. All right, now we're seeing some earthquake data. I don't know anything about these points. I can inspect a point, but I probably actually want to visualize this data in a way so that maybe I can find the strongest earthquake. So I'm going to right-click, edit symbology, and then select graduated. I'm going to use my favorite color map, Viridis, also the default color map in Matplotlib, and click Classify. So now we can see all the data kind of colored based on the magnitude, but it's kind of hard to differentiate the magnitude of all these because they're all pretty small earthquakes. So let's go back in there and let's change the classification mode from equal interval to quantile. Hit Classify, and there we can kind of see a little bit more differentiation between these points, but it seems fairly clear this one's the biggest earthquake. Let's check it. All right, that one says it's a magnitude of 8.1, and I know that's the maximum value, so awesome, found it. We can also visualize this data over time. We've got a time slider here. We can choose which attribute contains the time code, so I've got time selected. We can change the step. I'm going to change it to day. And then let's deselect that earthquake. There we go. And then we can kind of scroll through and see when these earthquakes are happening over time. We can also create a little animation, so I'm going to set it to 10 frames per second, start at the beginning, and click play. Cool, so those are earthquakes. Exciting. I just noticed there's another user avatar who's connected to my session, so I'm going to click on their avatar to follow them, and we can see what they're doing. I wonder if the following is stuck because of the Wi-Fi, or if I'm just missing something. Okay, there we go. We see a new layer just showed up, points of interest. So I'm going to right-click it, zoom to layer, and see the data that was just out. I need to turn off follow mode so that I can do that. Zoom to layer. And I see a couple of points that were added. I'm going to color them a little differently so I can see them better. Let's go with purple. Okay, so there's 3 points. I can see my collaborator's cursor. Let's investigate these points. I see this one says name rental pickup. So I think based on prior conversations, we're planning a paddleboard trip now. We've got a data point over here for the Santa Clara Community Park. And I see my collaborator has added a comment saying we should have lunch there. That sounds like a lot of fun. We can paddleboard over there. And let's look at this other point. This is Fanwell Street Park. I'm probably pronouncing that wrong. Okay, and here's a comment from my collaborator. I'm going to respond. So we're just having a little kind of Google Docs-like conversation. You're probably familiar with that. And we can hide these, we can delete them, we can view kind of the summary of all the annotations that have occurred on this document. We can zoom to annotations. I think we're going to look at one more layer here. Okay, there's another layer my collaborator has added. It's called route. We're going to zoom to that layer. It looks like this is going to be our paddleboard route. So we're going to pick up our rental here. We're going to paddle over to Santa Clara Point Community Park. We're going to have lunch. We're going to paddle over to Fanwell Street Park. And then we're going to head back. So that's our paddleboarding excursion planned. Awesome. Thank you, Fernando. All right, that's my demo. And let's get this set up again with my speaker notes. Thanks for your patience. Oops. Okay, F11. There we go. Okay, so oh, I've lost my notes. Okay, so you just saw some new ideas about what Jupyter's architecture, how Jupyter's architecture can be applied to the geospatial domain. And we want you to think about this. Where can the power of Jupyter's modular and reusable architecture enable new and innovative workflows in your domain of interest? We want to work with you to help make the geospatial ecosystem better, in particular, whether you're a practitioner, developer, educator, communicator, or artist. And if you're wondering, how can I be part of this awesome community, here are a few ways. If you can only do one of these things, please join us on the Jupyter Zulip. Zulip is like an open source Slack. I like it more than Slack. Everything is a thread. Every thread has a name. It's very easy to navigate and organize your content. And there's a GeoJupyter channel there. So you don't even need to register an account to view activity. It's open source and the conversations are open, but we'd love it if you joined in and registered an account. There's so many cool people there, and I promise you'll fit right in. In the short term, we're going to be participating in the community sprints on Thursday. I'd love to see you there. And there are a few other ways you can join us. We'd love to talk about your needs, your frustrations, and your opinions in an interview. You can click on that link to sign up. It'd be amazing to see you at one of our bi-weekly hackathons or monthly community meetings. You can view our community calendar on geojupyter.org, or again, you can follow the link on this slide. And Jupyter GIS is available for install with pip or conda or any equivalent. Try Pixie if you haven't tried Pixie. And if you follow the link on this slide or visit the documentation, as mentioned earlier, you can find a link to try Jupyter GIS with Jupyter Lite. So Jupyter Lite is a fully browser-native version of Jupyter GIS, meaning there's no server and nothing needs to be installed. You can just click it and go. We're really excited to hear what you have to say. Of course, we'd love to work directly with you on GeoJupyter projects, so you can check us out on github.com/GeoJupyter. And we have a special interest in, again, how you think that Jupyter's modular and reusable architecture can be applied to make geospatial data workflows more accessible and enjoyable. And finally, we're also excited to expand our funded development team. So if your company is interested in sponsoring this work financially or with engineering time, please reach out. And if you've got any questions, you can always reach me on Zulip. That's probably the best place, GitHub or email. And if you're going to AGU in December, we'll be there too, running a workshop and a session called Open Geospatial Workflows in the Cloud, and we hope to see you there. I want to thank everyone involved in this effort. There have been so many people and organizations working together to make cool stuff happen in this space. So special thanks to QuantStack for leading the development of Jupyter GIS, and to the Schmidt Center for Data Science and Environment for supporting me to work on this, because I've been having a lot of fun. One last huge thank you to all the amazing role models and mentors in these communities who have inspired me to become a better community manager and developer. And I want to quickly plug UV Panda's lightning talk at SciPy this year, titled "You Don't Need to Contribute More to Open Source, You Need to Go to Therapy." That's linked there at the bottom of this slide. And thank you for listening. I really appreciate your time and attention, and I hope to see you around.